So you all know how we are going to start with the TinkerCAD, and for IPCL lab we are using this TinkerCAD as a simulation software or a platform just to simulate all the circuitry before working on the hardware. Okay, so for that purpose, now this is your main screen of your TinkerCAD. After logging into it, you will see this screen. Now I have already created classrooms for you. Okay, so for each batch, that is SY3A and B and SY4A and B, I have created four classrooms, and I have shared that links on you on the WhatsApp, right? So you have many students have joined, and yet those who have not joined the classroom, please join it so that I can evaluate and I can go through each of your circuit whichever you are working on. Okay, now to start with any of the new circuit, you have to go into design. In design, create circuit. Okay, now this is your window where actually you are going to create a circuitry, and here you are going to simulate it. So if whatever circuitry you are going to build, you can give the name for that circuitry. Initially, if I want to work on LED interfacing or LED blinking, so whatever name you want to give as per your experiment, you can give. Okay, and after that, now here you see there are different views: circuit view, schematic view, and the component list. I hope it's visible. Yes, everyone is on the page, same page. Yes, students.
Yes, ma'am.
Okay, so this is your circuit view. So in a circuit view, actually you are going to build up a circuit. So whatever circuitry in the hardware form you have, that same circuitry you will visualize over here, and that view is called as a circuit view. Now here, which type of components you want to select, that will be selected from this tab. So basic components means all the basic components you will find. If you want any Arduino, already built up Arduino kits with some examples, with some application that are shown over here. Okay, so list of experiments with Arduino Uno are shown here. Now out of it, if I want to select one of this, that is of LED blinking, I will select one board. I will just drag and drop it over here on my white screen. Okay, on this blank screen. So on this blank part of my TinkerCAD, I am going to place a circuitry which where I am selecting from this Arduino examples. So first I am selecting that is LED blinking. Okay, now so this is simple circuitry where one LED is being used and it is connected to any one of this pin. So we all know that 0 to 13 pins are our digital pins. This A0 to A5 are analog pins, and these are the pins like your 3.3 volt, 5 volt VCC and ground pins. Okay, so whatever pins we are going to use to interface the LED over here, now there are some pins shown with a tilde sign over here. So these pins means that are used for the digital PWM, pulse width modulation. Okay, and these pins can be utilized as a general input output pin, GPIO pin also, or it can be used for digital PWM also. Okay, so don't bother about this tilde sign over here. So you can use any one of this pin from 0 to 13 as a digital input output pin. Okay, now LED. When I am talking about LED, how to use a LED? Now while using a LED, if you will click over here on LED on each of this terminal, it is indicating that whether it is a cathode terminal or a anode terminal, right? When practically you visualize a LED, in lab also I have told you how to recognize it. If the terminal, the height of a terminal, the length of terminal of a LED can be used to identify the cathode and anode. So the longer terminal will be denoted as a anode, and the shorter length terminal will be your cathode, right? And even from the inner sections of the LED, you can visualize the smaller part section is considered as an anode, and the larger part section within LED, that terminal is considered as a cathode. Okay, now LED can be connected in two different ways. We call it as a common cathode or common anode, but instead of that, even you can say that how the LED can be used. I can use a LED by providing my digital signal to the anode or to the cathode. If I am providing a digital signal to the anode, then the cathode should be connected to ground or VCC. Anyone? If the signal is provided through the anode, the cathode will be connected to ground or VCC.
Ground.
Ground. Okay. And if I want to connect or give the signal through the cathode, then the anode will be connected to VCC, right? So in this way we can use the LED. Now this common anode or common cathode concept of LED is more recognized in the LED, which are the RGB type of LED, where you have three different terminals to recognize, to indicate the light in three different colors, that is red, green and blue, RGB. Okay, so there mostly this concept is being used. And whenever you are connecting multiple LEDs, now here while connecting multiple LEDs, each of this cathode terminal you are bringing to one ground terminal, right? Similarly, whenever we are connecting this on the breadboard, we are making all the cathodes together as a common cathode, and we are providing the signals through the anode, and the vice versa. So we call this concept as a common anode LED concept, or common anode LED connection and common cathode LED connection. Is it clear? Now, how to identify the code for this circuitry? As I have directly picked up the circuitry from the whatever circuitry is available on this TinkerCad. So as it is available, the circuitry is available already built in, so I can find out the code, what is the code for this circuitry. So go in code, in this drop down menu, click on text and say continue. So you will get a code. Now in theory also we have learnt that how the code is written for the Arduino. The code is written in two sections, void setup and void loop. So in these two sections, while writing a code, we are using void setup to define, to set up the pin configuration, that how we are going to use each of this digital or the analog pin, because each of these digital pin can be utilized as a input or as a output. Okay, so the pin mode is a function which is the inbuilt function in Arduino, which is used to define the mode of the pin, how we are going to use each of this pin. If I have connected anode to this 13th pin, how I am going to use this 13th pin, whether it is a input pin or a output pin. So it can be decided in two ways. First, identify which type of sensor or which type of device you have connected to your digital pin. If that device is an output device, then that pin mode should be output. If that device is an input device, that pin mode should be input. Is it clear? For example, LED. Now LED is an output or an input device?
Output.
Output device. So as LED is output device, your pin mode for LED should be output. Okay, and here you have to write the pin number to which you are connecting your LED. Okay, so 13 pin number is called as a LED built-in because there is one LED which is already connected to the 13th pin internally on the Arduino, and the name for that LED is given as LED built-in. So we call this as a, this pin can be named as a LED built-in, or you can write a number of this pin as a 13. So it's one and the same. It will not show any error. Okay. So in void setup, first you have to set the pin mode. In void loop, you have to provide the direction that how this pin should be operated, right? So how this pin is operated will be written in the void loop. So for that purpose, there are some digital functions available in Arduino. So as LED is a output device, we need to write something over the output device. We cannot read the output, right? We have to provide the output. So to provide the output on the LED, I need to write something over it. I need to send some logic to the LED, and that can be done by using a function digital write. So digital write is a function used to write something over the logical pin to which you have connected your LED. So digital write, then the number of a pin and what type of logic you want to send to that pin, whether it is high or low. Okay, and the delay is written because I need to identify the high and low signal on the LED, so I am providing a delay. So delay of 1000 means this delay is always in millisecond in Arduino. So whenever I am writing is as a 1000, so it is a 1000 millisecond means a delay of 1 second. Okay, so depending upon the problem statement, whatever delay you want, mention it in a millisecond while writing this delay function. Okay, so high and low, I am making high and low LED just by providing a delay of 1 second in between. So this I want to repeat till my program is under simulation, till I have provided the power to my circuitry. So I have written all this statement in a void loop. So it will be in a loop for the infinite time till I have provided the power to this circuitry. Is it clear? So after this, after writing a code, after understanding a code, directly you can click on a start simulation. Okay, so after clicking on a start simulation, see your LED is blinking. It is blinking high and low. I hope it is visible. Yes, everyone?
Yes, ma'am.
Okay. So now I will stop. Now if I want to make any change in the code, first you should say stop simulation and make the changes as per the requirement. Okay. Now if I want to see how is the schematic view for this circuitry. Now this is just a circuit diagram. This is actually a circuit or a hardware which you visualize and you are going to work on. Now how it is a schematic means how internally while making a connection, how actually the connection is being made, how this LED is being interfaced to Arduino. To know that, see here we have created a circuit view. Now here I will go to the schematic view of this circuitry. So just click on this and you will get a schematic view. And this is the schematic view which is being shown in your write-ups also. Have you gone through the write-up? So this is the schematic view. So schematic view tells you how actually we are connecting a LED, how the anode is connected, how the cathode is connected, and how we are providing a or how we actually execute this code for the LED blinking. Okay, and then if I want to know what are the components required to interface a LED. Now I have done the simulation. First I was known to the problem statement. I have built up a circuit in the TinkerCad. I have written a code. I have executed it.